Hey, folks. Yeah, it's my pleasure to introduce to you Peter Lai. He has over 25 years of experience in the manufacturing industry with vast exposure in production management, continuous improvement, operational excellence, quality sales, IT, Lean Six Sigma, as well as in the IoT tech as well. Peter
Yep.
leads...
Hi, everyone. Yeah, can you hear me okay?
Yes, we can hear you, Peter.
Yeah, great.
And the topic for the session today is starting small and scaling fast with digital transformation in the manufacturing domain. And with that, Peter, it's my pleasure to welcome you. The stage is all yours.
Okay, so I've had an introduction. So yes, Peter Lai, I'm continuous improvement and 4IR manager. So 4IR manager is a fourth industrial revolution. Okay, so today we'll dive into an introduction of the NSG Group and NGF Europe and explore our digitalization journey and try and understand our push for data acquisition and see how we're starting to unlock powerful insights from that data. Okay, so let's get started. Okay, so these three elements I just wanted to touch on at the start of my presentation. First one being cloud. So think of cloud as our virtual vault, enabling instant access to data without any physical barriers. IoT. So in essence, it's hardware intelligence from sensors transmitting via connectivity, storing, analyzing data, and then transforming that data into meaningful information. And finally, operationalizing through applications. Final one is big data. So not just about volume, it's complexity. And with the right analytics platform, we can unlock profound insights. So a bit about NSG. So we're a global entity with our products reaching over 100 countries. We've got three major divisions, and these are classed as automotive, architectural, and creative technology. My expertise and my role lie in the exciting realm of creative technology and functional products. So our site stands as the largest among NSG Group's 5 glass cord facilities. We operate 24/7, usually around 353 days a year. We only shut down for maintenance, and we have a dedicated team of around 250 people at the site where I work, which is based in the UK, St Helens. So glass cord, and you can see that in a couple of the pictures. So in the top picture is glass cord, which is in the middle of a timing belt that's used in cars. You can also see some newer markets, so an electric two-wheel bike on the bottom, and also a typical cycle bike. So glass cord is essential in reinforcement of belts in not only automotive but in industry, and that drives our innovation. As leaders in modern mobility and environmental sustainability, we were honoured to be 2-time recipients of the Queen's Award, once in 2001 for trade, and then more recently innovation in 2014. At the heart of our production line lies the versatile glass cord. So you can see that in the top left picture. So this is a critical component and reinforces synchronous drive belts across both industry and automotive sectors. And it doesn't stop there. It actually also strengthens tires, ensuring durability and safety. So you can see some of the belts in the top right as well. Diving into the cosmetic world, so we have a product called MetaShine, and that serves as a radiant additive, elevating the allure of beauty products, so makeup. And lastly, we also have Glass Flake, which takes center stage in enhancing automotive finishes, so paints, car paints, and fortifying anti-corrosive paints, which are used in wind farms and oil rigs. Anything which you need paint is being anti-corrosive. And that showcases not only our commitment to both aesthetics, but also function of the product itself. This slide shows our sites, so our 5 sites for glass cord manufacture. So we have the UK, we have Canada, Japan, China, and Poland. At NGEF Europe, our approach to innovation is systematic. So every project kicks off with a proof of concept. You probably refer to this as a POC. So when a POC proves its merit, it's not just about validation. We then actively strategize how to implement this and then swiftly scale, with AWS playing a pivotal role in accelerating this scaling process. Guided by a weighted matrix, which we've used for quite some time in continuous improvement, we assign priority to each project based on what the benefits are, based on cost, based on how long it'll take us. And then we add those and chart them into an ambitious 5-year digital roadmap. So you can see that on the slide, just an example of a roadmap. And here we integrate transformative tools that foster productivity and collaboration throughout the business. So what's our end game? Our end game really is to seamlessly align our digital evolution transformation with the broader vision and immediate objectives of the business and the wider group as well. So we have a 3-step maturity model. I know that many people have different numbers in their maturity model, 3, 5, 7, I've seen many, but just to explain ours. So first one being visibility. It's really about achieving real-time insight into every factory operation, manufacturing factory operation, so we can ensure we've got informed decision making. Next, connectivity. This is all about integrating systems across factory and ensuring seamless communication and efficiency. And then the final one is optimization. So act on data insights to improve processes, enhance automation, maximize productivity. And our maturity model transforms our factory into efficient, data-driven, agile entities. So as we progress, operations become more streamlined and effective. So a bit about how we formed our data story. So the historical context. So our data journey began quite modestly. We recorded some asset data, but mostly stayed dormant and unused. I think that's quite typical in manufacturing. You collect a lot of data, but it kind of just sits there because they're on different systems. Every day, someone would manually pull production reports from systems such as SAP, or we've got an inbuilt QA platform. And that is very time consuming. And often we would only really do it reactively. If we've got a problem, let's pull this data, let's try and match that up with live production data, etc. And we didn't have a regular deep dive into data analytics. So a lot of potential insights remain untapped. And then how did we transform? So enter AWS and IoT. They've really been game changers. So as you can see on the diagram on the right, you've got AWS being central. And it was quite some years ago, probably working on and off now with AWS for 4 years. But I always struggle to find how can we join all of these data sources together? And that's where AWS comes in. So now instead of us having scattered data pools, everything is funneled into a singular cohesive platform. And we use tools, Greengrass, SiteWise, IoT Core. And I think what's truly exciting is we're not just looking at numbers now. With the future capabilities of AI and ML, we're deriving complex, actionable insights that were previously elusive. And I'll talk more about that in my presentation. So as we've transitioned, our data isn't just about numbers anymore. It's a story, one that guides decisions, strategies, and future innovations for our manufacturing sites. So here's some examples of just a few of our early proof of concept projects. So starting at the first top left is gateway to AWS. So we've implemented a laser light level sensor directly on our production bath. So where we coat glass cord, it runs through a bath of chemical latex dip. So what's its job? And so its job is to precisely monitor the depth. Now, some of these machines were quite old machines with very limited connectability. So we decided to use a gateway and use AWS. Now, it's still not standalone. It's integrated with our internal data network, and it provides us with live readers. And the best part, we're eyeing a substantial cost reduction and savings of around 11,000 annually by just doing this. So take the next example, MQTT to AWS. So again, so this is the middle one. Focusing on our binder tanks, we've placed a level sensor for effective remote monitoring. Connectivity, so much easier, seamless. So we've done this wirelessly, linked to an IFM gateway through an IO link master, which is very standard protocol and equipment. And we're again looking at potential savings of around 13K each year. The final example, acoustic vibrational sensors. So we have some of our machines on the right, and to ensure they run smoothly, we've installed some IFM vibrational sensors. Now, these don't just alert us to when something's going wrong. As now we're in the age of predictive maintenance, the sensors let us anticipate and address issues based on the machine's actual performance. So the actual projected impact is a cool saving of around £5,000 per machine per annum. So again, all of these savings add up, and these are just a selection of some of the smaller proof of concepts which we've done. So our digital transformation, with united diverse data sources into an integrated framework with real-time dashboards. We're not just observing, but acting upon crucial KPIs now for the business. The most important thing, we're also ensuring security at each step. Our technical landscape has changed over this last 4 years. We now have over 600 PLCs and counting. We've got a robust QA system, again, which is a third-party system, which we've written part of it in-house with 18 daily checks for each product and our dedicated on-site R&D. And we're expecting to expand our IoT devices. You know, we have 100 now. We're expecting to expand these to around 500 in 2024. But as the data influx grows, so does the challenge of managing it. Our response to this overload, a strategic embrace of automated AI and ML solutions to streamline and optimize our data journey. So here's some dashboards. So what you can see, and I've had to blur some of the information out on the right to protect our IP. But really, as we've propelled forward on our smart factory journey, one crucial move was to make the data visible right where the action happens, on the shop floor. So we use AWS managed Grafana. Again, it's managed in AWS. So from a security perspective, this is something we were looking for. It wasn't just about collecting data, it was about making it understandable and actionable. So with this tool, any data we gather transforms into insightful visuals, making complex data sets digestible at a glance. So, you know, typical traffic light system, if it's green, it's good. If it's, you know, if it's yellow, orange, you may have an issue. And if it's red, you have a problem. Underlying this is the SQL environment, and we also use SiteWise for real-time data, AWS SiteWise. But SQL, a powerhouse for data transformation, it lets us mold and shape our data into the exact form we need it. So we use a mixture of SQL and a mixture of SiteWise, so live data from PLCs. And this gives us an operational impact. Before, benchmarking and performance tracking was a tedious monthly affair. We're now in the age of real time. So teams now can see how they're doing instantly, adjust things on the fly, and strive for constant improvement. I was a production manager for the best part of 10 years, And one of the most frustrating things was, you know, at the end of the month, so if it was July, I would probably get the end of July, I would probably get the figures for July this week around now. But obviously, you know, that's 38 days after that month started, so there's nothing I can do about it. So really to finish really, Grafana isn't just a tool, it's our window into real-time operations, pushing us closer to our vision of a truly smart factory. Significance of data insights. So this was just a project which we carried out just a couple of weeks ago. And what you can see in the top picture is some fiberglass. So fiberglass which has been wound onto a cardboard tube. It's very, very thin fiberglass, 7 micron. If you think your hair in your head is 50 micron, it's wound very, very thin. At the heart of our operation lies a conditioning room. So these glass fiberglass cakes, we call them, go into a conditioning room, and it's a pivotal space where our glass undergoes drying and tempering process, and it's a crucial process to the overall quality. So the problem we had was we stumbled upon quite a challenge. Some of our glass was exhibiting performance issues during the secondary process after this. So our hypothesis was it's likely linked to the drying process in the conditioning room. And although we had data to tell us the temperature, humidity, pressure, etc., it wasn't really enough. The room is quite big, and you know, for me, it was, well, let's bring in some more sensors. So you can also see on the right hand side, we've actually started 3D printing our own temperature and humidity sensor cases, and we actually build our own temperature and humidity devices. So we didn't remain in the dark. We harnessed the power of in-house developed industrial Internet of Things devices, and we turned our passive observations into proactive intervention. So these devices, and you can see this on the graph, provided real-time data for not 1 or 2 positions, but 15 distinct zones within this conditioning room. So again, you know, previously you would embark on a project like this, and this would take you weeks. You would have a big capex, etc. This took us a week, and we had it all in and done, and actually had insights out of it. So what was the outcomes? So armed with the insights from all of these devices, we could pinpoint issues. So then, from a continuous improvement perspective, we could tailor our approach and enact meaningful improvements based on our data what we're seeing. So the result, how did we get? Enhanced glass quality and smoother downstream operations. So this was a project we did in a couple of weeks because the technology was there, the infrastructure was there, and the visual data was there. So this journey really underscores the importance of data in modern manufacturing. It's not just numbers, it's a roadmap to excellence. So AWS Monitron, so Amazon's own Monitron sensors. So as we strive for cutting edge solutions, we started trialing Amazon's Monitron sensors on site. And Monitron sensors are an acoustic vibration sensor. So you can see these in the picture. You can see just in the top right picture where we've circled it, and we've circled around them. So they're very small devices. And they're battery operated, very low costs. These aren't your everyday sensors. They provide hourly readings in both vibration and temperature, and the longevity, you get a whole 3 years out of these sensors, and then you just replace them. I think 5 sensors now in a gateway is around $400-500 to buy, so really low cost. So if you're wondering about what their efficiency is, I was lucky enough to go to one of the Amazon warehouses quite local to where I work. So it's in a Warrington-based one, and Amazon actually use in their warehouse network 950 of these sensors, and they have an operational uptime of around 99.8% in their vast warehouse network. So its reliability is tested and proven. Our experience, you know, we haven't just added these for tech's sake. These sensors help us shed light on issues. And again, you'll see something shortly with some very large extraction fans, and we put them onto pumps and motors, and it's amazing the results we're starting to see. And this is guiding our maintenance teams and their efforts more effectively. So in essence, Monitron isn't just a sensor, it's a testament to how the right technology can propel operations and manufacturing to new heights cheaply. So this was just a slide I just threw in. Over a span of 14 days, we compared an AWS Monitron sensor that's highlighted in red, the red dots, with a more expensive acoustic monitoring sensor, and they're highlighted in blue. Monitoring vibrations averaged over 1 hour. So the graph on the right, the statistical analysis revealed quite fascinating findings, really, that the R values indicate that remarkably there's no significant difference in the vibration monitoring capabilities of the two sensors, of course, with what we were measuring in this instance. But what it does say for what we were measuring in this instance is we can install Monitron sensors for 1/10 of that cost. So again, just shows how cheap the technology can be and how useful it can be in manufacturing. So the next area I wanted to cover was AWS Lookout for equipment, so predictive maintenance. So NGF, our pursuit of excellence, brought us again to look in for a lookout for equipment, with being able for us to become reactive, to becoming decisively proactive in our maintenance strategy, really. So moving really away from just reactive, this machine's broke, to, yeah, it telling us what it can do. So this service isn't just about spotting a glitch. Lookout for equipment is an anomaly detecting marvel, in my opinion. It has the potential to drastically minimize unplanned downtimes, optimize maintenance costs, and boost overall equipment efficiency. Diving a bit deeper, this service leverages the prowess of machine learning. So it analyzes sensor data from the crucial equipment components like motors, conveyor belts, pumps, air pressure, temperature, etc. And then you can build a model what represents normal behavior. And then any deviation from that behavior, it catches it. So what's the operational impact? And what does it mean for us on the ground? So using Lookout for equipment has now armed us with invaluable insights. Our decisions on maintenance and operations are now data informed, ensuring precision and improved equipment life. In essence, Lookout for equipment, we're not just about maintaining, we're anticipating, acting and optimizing. So it's another big step in our digital transformation journey. So NGF, while we have a number of different gas operated ovens, we had a one particular oven what's always been a bit of an enigma, and it's exhibiting kind of perplexing performance patterns which we haven't been able to really get to the bottom of, and this issue has been close to 2 years. Not only does this particular oven lag in, product processing from an OEE point of view, but our data also indicates that it uses maybe 15% more gas than its counterparts, even under similar operational conditions. So we've looked out for equipment, we dug deeper, and what we found was eye-opening. So what you can see on the very top graph is you can see a normal operating oven, and you can see that it's got 3 anomalies. They're shown by the green bars and the multicolored bars over 2 years. So things are running well. The problem oven, which we kind of expected and hoped by using Lookout for equipment, you can see is the very multicolored one in the middle. So you can see the green bars showing the anomalies, and then the multicolored bars showing the significance of importance of which sensor you're actually looking at. However, the one at the bottom, what we found was even the ovens which were believed were performing optimally in spec, everything's happy, no particular processing issues, were also exhibiting anomalous events. So you can see that on the bottom one. So you can see that in the same time period, you can see it's not quite as bad, but much worse than the one at the top, and it's getting worse. So these other ovens also had suboptimal running, which we were not picking up with standard equipment. So the revelation was really diagnosing that we found an extraction fan issue, one that has eluded traditional inspection methods, maintenance techniques, and without Lookout for equipment, this challenge might have remained hidden indefinitely. So this journey with AWS Lookout equipment underlines a key principle for us. Equipped with the right tools, no inefficiency remains hidden for long. So again, it's a fantastic insight into a service, which for manufacturing is such an important piece of software which we can now use. Okay, so next steps for us. Grafana's growth. So as today, Grafana boasts over 80 dashboards in our site, but we're not stopping there. We're aiming by the close of 2023, we're looking at impressive 120 dashboards in manufacturing. Our commitment to Grafana extends just beyond our current operations. We intend to integrate AWS into our global sites. Grafana adaptability makes it a clear choice. So we're looking at implementing Grafana, firstly in NGF Canada, and then following on to NGF Poland. Currently, Monitron, currently we have around 20 Monitron devices on site, but by the end of the year, we're scaling that to 50. And we're going to take that global too. Our trials are already starting to show promise. So a proof of concept will be introduced to both NGF Canada and Poland come November, December 23. So our efforts, have also caught the attention of the AWS Monitron team. So I've been speaking to them, and there's the potential of us working towards a joint case study on this, but also looking at the new features of the new Monitron, which is coming out in their roadmap as well. Fast forward to September, we're looking at launching our live pipeline for Lookout for equipment. So this will mean what you've seen in that previous graph where we were looking at Lookout for equipment. This data will be coming in live. So then we'll be able to deploy that to our other sites again if successful. So NGF Canada and Poland next year. AWS has supported us, wholly probably through this exercise, assisting us in not only data visualization, but also helping us to understand the analytical depth of the data we were looking at. Okay, TwinMaker. So AWS TwinMaker, we're always on the hunt for innovations that can propel our operations to greater heights. And that journey led us to AWS TwinMaker, an advanced tool to digitally recreate and simulate our manufacturing processes. It's worth notice that our belief in this technology isn't just internal. We were also awarded partner funding through Storm Reply to carry out this promising proof of concept. AWS TwinMaker isn't just a visualization tool, it's an optimization powerhouse. Manufacturers like us can use it to fine-tune processes, dramatically reduce waste, elevate product quality. With real-time monitoring, our decision-making is no longer based on intuition. It's data-driven, precise, impactful, and it transforms how we oversee our manufacturing processes. Beyond just operational efficiency, TwinMaker paves the way for significant cost savings and, importantly, a boost in profitability. So to offer you a closer look, I've a 2-minute video showcasing our digital twin in action. Do note that I've had to edit the view slightly just to safeguard our intellectual property. So I'm going to play this. There isn't any sound. I'm just going to talk over that. So I'm just going to start this video now. Okay, so we work with AWS Storm Reply on this digital POC. And what you can see here is this is data, a Matterport image from our new machine and oven. It only took us about an hour and a half to do this. Although, as you can see, the first image was kind of a bit dull, bit grey. But working with AWS and the TwinMaker team, we were able to just import this live model of our factory straight into AWS TwinMaker. So what you can see here is our glass cord, and our glass cord is going to get coated through the oven. So one side gets coated, the other side is black. It's been coated with a compound in its final process. So that's a dipping process. What you can see now, you can see blue tags. So I click on that tag, I can now see a zone temp, and that's the live temp. So 105, 104, etc. Zone 2 temp, 113, 115. So this is showing you how to use TwinMaker. So in this demo, I'm also showing you how to add a tag and how easy it is to add a tag into TwinMaker. So what I'm doing, we're going to add a tag for zone 2 pressure. Okay, so we're going to choose an icon. I'm going to distinguish it with an exclamation mark. We've already got a SiteWise link to zone 2 pressure, and you can see there we're just filling in the fields, we're filling in the property name, and then we are going to drag the tag to a location we want. We're then going to refresh this. So we'll refresh it now, and then we'll be able to click it and see live data. So there you go. So in less than a minute, that was slightly speeded up video, but in less than a minute, I have added a data field to a TwinMaker form. As you can see, I can click on bath temps, and again, I can see more live data. So I think the point I was getting across with this video is fantastic from a visual point of view. You can really start to see where your data is coming from. So in manufacturing, that's key, but also how easy it is for us to add extra data points. It's something we can do ourselves. Okay, so just moving on. So coming to final slides now. So our digital twin technology continues to flourish. I think soon sectors like quality, EHS will embrace its capabilities. We're eyeing exciting frontier now with AWS, which involves running simulations with this digital framework. So what happens if this machine breaks in your process? What's it going to do? And the future now seems more interactive too, with team leaders being able to access machine metrics via augmented reality during shop floor rounds. So when they're walking around, look at the machine, what are the metrics? Greener future, our internal projects aimed at understanding the return on investment of EMS systems have come to quite close to conclusion now, and the results are really encouraging. So again, collaborating with one of AWS partners, CoolPlanet, we've been able to implement some on-site metering techniques, and they're showing that a promising reduction in CO2 emissions from some of the opportunities they've highlighted. As we step into October, we're gearing up for our ISO 50001 audit. And I think with the work we've done and the momentum with the EMS collaborations with AWS and CoolPlanet, I think we're on a positive trajectory for that. Finally, NSG sustainability pledge. So we have a long-term vision by 2030 of 30% reduction in both direct and indirect emissions, and supply chain emissions is our set target. Our ultimate mission, carbon neutral by 2050. A lofty ambition, but one wholeheartedly we embrace. And then in conclusion, so our collaboration with we also do a lot, maybe another presentation in the future with AWS Restart graduates, and that has been immensely fruitful. So I'm showing you this example here. So this is our resident NGFBs. So this project really exemplifies the thrill of digital innovation. So by employing IoT, we're monitoring temperature, hive, weight, and even live video feed of our 40,000 bees, which we have on site. This integration of nature and tech represents the very spirit of our initiatives and just shows what you can do simply with innovation and IoT. So that's the end of my presentation. So thank you for your time and attention.
Thank you, Peter. It was fantastic. We have a couple of questions here from the audience. So we'll take them in the order that's been received. First one has to do with what kind of storage do you have for persisting sensor data in AWS?
So storage, so we have, so we use IoT Core, we have S3 storage as well. Yeah. So we also, so from a data point of view, we have a lot of data coming in from SAP HANA. We have SQL databases pulling in third-party applications. They go into an RDS server, and then for our non-relational data, sensor data, etc., that goes into an S3 bucket. Does that answer your question?
So this question was from Faraz Memon.
Yes, thank you.
Yes, brilliant.
Fantastic. We have another question from Simone Samir. Question is, as we are using PLC-related workload, are we facing any performance issues? Since in general, large size of image files might involve in PLC-related workloads.
To be honest, no. I think we started our journey certainly looking at PLCs and SCADA. Started that around 4 years ago, and so we were collecting data anyway locally first. So we were using just SCADA-based collection software, but now we're moving all of that data into the cloud, and I think. One thing, I think is worth making a note of at first, depending on the PLC and what that's actually monitoring, yeah, you can have data overload without any doubt. And I think what we tend to do now is we look at the data. If it's critical data and we need it at a frequency of every second, then we will put that into AWS in that time frame. But most of the PLC data we have can be summarized. So if we don't need, putting it in every second, we don't need to see data or visualize it in that way, we'll put it in every 10 minutes or every hour. So again, obviously that reduces cost, I think, into the cloud, but it also stops you just hammering your network and sending unnecessary data. So that took time, and I think it took quite a bit of a learning curve for us to understand what was acceptable, what speed is acceptable. And of course, at first, you always start off with probably too much data and then just scale back. Hopefully that answers your question too.
Thank you.
Okay, thank you.
Thank you. I do have one additional question. So
okay.
How do you incorporate resiliency into your architecture?
Okay, so currently, I mean, from, at the moment, we're collecting data, so we collect data locally, so on the edges, and obviously we have resilience in our local servers. But in terms of our data going into the cloud, we have a gigabit connection up and down, which obviously certainly suffices the amount of data we're putting into the cloud. It's very much underused. But then as we started to progress and the use of Grafana, the use of data analytics is becoming much more essential for the business, meaning that if we lost our gigabit connection, what can we do? We actually have a separate, slower connection, but in the event of an outage, we would still be up and running. So, yeah.
Thank you. Back to the audience. Are there any additional questions? Thank you, Peter.
Thank you. Thanks, everyone.